In this lesson, we're going to look at updating and deleting documents. Now, the mechanism for doing so is quite straightforward. What's more interesting is what's happening under the hood. So we're going to focus on the architecture and process a bit. So an RDBMS and Couchbase are fundamentally different in their architecture. With an RDBMS, as data comes into the system, it's written to disk. Then it's logged for availability. Then it's finally indexed and cached in memory so that you can seek back to disk when appropriate to get the underlying data. The point being, virtually all your reads and writes need to seek on disk. By contrast, Couchbase has a memory-first approach. The key and potentially key and value are cached immediately in memory and then indexed. If you've configured to do so, the key and value are replicated to additional nodes in the cluster for availability, and then the data is written to disk, or potentially not. Buckets as of Couchbase 5.0 can be completely ephemeral if your data is transient. The point being, all your reads and writes can be served immediately from memory. So how does this work in relation to updates and deletes? Well, as we've seen in a prior lesson, your updates happen by appending to the write log in memory. Deletes also append to the write log. They just append what's known as a tombstone, indicating that this particular document ID is no longer available. The next time a get operation, or select in the case of nickel, seek that value, it will be reported back as not available. Now this does mean that over time the data files being generated from these write logs can grow large from duplications, so periodically they're compacted. Duplicates with older timestamps are evicted, and tombstones along with the tombstoned documents are also evicted. From this, a compacted replacement write log is built and put back online. This whole process happens with zero downtime. So how do you update a document by replacement? Well, you would likely put this in a put operation in a REST API, but it's the replace method. That is one of the approaches to do a update. You assemble your document, and you assemble your key, and then you pass the key and value to the replace operation of your bucket. Under the hood, this is appending to the write log. The key point here is that with a replace operation, a key scan occurs. And if the key does not already exist in memory, if the document doesn't exist to be replaced, then an exception is thrown. Now there's another approach that is potentially even faster. You can update by insertion or replacement. This is done through what's called an upsert operation. Now upsert works just like a replace. You assemble your document ID and your value, but in this case you pass them to the upsert method of the bucket. This also simply appends to the write log. The difference is that in this case, if it doesn't exist, it's simply created. If it does exist, it's replaced. What this means is that under the hood, there's simply no key scan happening before the value is appended to the write log, meaning upserts are extremely fast for ingestion. So how do you delete a document? Well, that's quite straightforward. You just pass a document ID to the remove method. Under the hood, this is appending a tombstone to the write log, which means the next time a get operation or a nickel select seeks this document, it's reported back as no longer available. So what have we learned here? Well, because it's memory first, Couchbase is extremely fast. With proper sizing, all of your reads and writes can be served directly from memory. All of your mutations are handled by appending to a write log. If it's an insert, a replace, or an upsert, a new entry is appended to the write log. If it's a remove, that appends a tombstone to the write log. Regardless, you're just continually streaming values to this write log, which is then periodically compacted. Under the hood, a key difference is whether or not your update process performs a key scan. A replace we'll do a key scan and throw an exception if the key is not there, which can be logically helpful if you need to know that, if you need to know if I have this data already. But if you're just ingesting, an upsert doesn't even bother with a key scan. It just continues bringing in data, effectively inserting or replacing as relevant. In the lab, you're going to update documents via a put route, creating or replacing documents as needed and learning from seeing the various exceptions thrown or not thrown, and then you'll delete documents by removal. Then come on back. Our final lesson is going to touch on working with Nickel, our powerful analog to structured query language, and how you can put it to use through the SDK for PHP. Stick around.